This video here is to help you draw Lewis dot structures. After watching this video, you should be able to draw Lewis dot structures for molecules with a single bond, double bond, and a triple bond. Let's find the valence electrons for NF3. To find our valence electrons, we use our periodic table and we look at our S and P electrons only. The most valence electron an atom can have is 8. Nitrogen has 5 valence electrons. There are 3 fluorines. Each fluorine has 7 valence electrons. So if we add these all up, this is 26 electrons total. To review this, nitrogen has 5 valence electrons. We look at just the S and the P electrons. We add up the S electrons and the P electrons, and that's where we get our 5. Fluorine here, its electron configuration is 1s2, 2s2, 2p5. When we add up these electrons here, that's where we get the 7. Again, the 26 electrons that we get from adding up the valence electrons is how many electrons we're allowed to use in our structure. Once we figure out how many valence electrons we have, we're going to arrange the atoms. We're going to arrange the atoms so that they look symmetrical as possible. So in this case, nitrogen would be in the center, and we'd surround it with 3 fluorines. Now, because these atoms are in a molecule, they need to be connected with a bond. So we're going to draw a single bond, single covalent bond, to connect the atoms to nitrogen. This single covalent bond represents 2 electrons. So if we look at this, we can see that nitrogen now has 6 electrons around it. It needs 2 more electrons to get a full octet. Whereas each fluorine here, because it has just that one bond that represents, again, 2 electrons, we need to add 6 more electrons to fluorine so that it has a full octet. Now, all the other fluorines also need 6 electrons. And so we're going to complete our octet for all the atoms here. There are 2 exceptions. Hydrogen and boron don't have a full octet. The next step in figuring out if our structure is correct is to count our electrons in our structure here and compare it to the number of electrons we're allowed. We're allowed 26 electrons, and if we count up all the electrons in our structure, we also have 26. So knowing that, we're done. If the numbers don't match up, we would need to redraw it and try a double bond or a triple bond. Our next structure we're going to look at is CH4. What I'd like you to do is hit pause, practice writing down how many valence electrons there are, arrange the atoms, give each a full octet, and compare your numbers. And I'll go through the steps with you after to see if you did it correctly. So push pause and try it out. All right, so we first need to figure out how many valence electrons there are in this structure. Carbon has 4, and each hydrogen has 1 valence electron. And since there are 4 since there are 4 hydrogens, there will be 8 electrons allowed total in the structure. Now we're going to arrange it. We're going to put carbon in the center, and we're going to connect 4 hydrogens to this compound. Now, hydrogen is an exception to the octet rule. Hydrogen should only have 2 electrons, so all hydrogen will ever have is a single bond. If we look at carbon now, we can see that carbon has if we look at the electrons around it, we see that it has 8 electrons. So it is happy, and we don't need to add any more electrons to it. So if we look at the electrons in our structure, we have 2, 4, 6, 8 electrons around carbon. That's all that we have, and that is how many we're allowed. So this here is our correct structure of CH4. Our next example is going to be with HCN. Again, I want you to hit pause, try drawing it on your own, figure out how many valence electrons you have, and then figure out what you might need to do to make this drawing correct. And this is one where you'll have a double bond or a triple bond here. What we see is that in this structure, hydrogen has 1 valence electron, carbon has 4, and nitrogen has 5. So in this structure, we should have 10 electrons allowed. When we draw it, we're going to put carbon in the center, and we're going to connect both nitrogen and hydrogen to it. Now, if we look at carbon, there's only 4 electrons, so we need to add 4 more electrons to this structure. Nitrogen now only has 2 electrons around it, so it needs 6 more to get a full octet. When we draw the structure and give everything a full octet, again, hydrogen only has 2 electrons, so I didn't add any more to it, we see that we have 14 electrons in this structure, which is too many. So what we're going to do is we're going to redraw our structure. Hydrogen can only have a single bond, so we're going to try a double bond between the carbon and nitrogen. Again, we'll look at that number up here of valence electrons after we give all our structures, or all our atoms, a full octet. And what we see is that carbon has 6 electrons around it and needs 2 more for a full octet. Nitrogen needs 4 more electrons around it for a full octet. Counting up our electrons, we have 12 electrons, which still is too many. So the next thing we're going to try is drawing a triple bond between that carbon and nitrogen. Looking at carbon, we see that we have 8 electrons around carbon. Nitrogen has 6 electrons and only needs 2 more. So we are all done. We have 10 electrons in our structure, and this is the correct structure for nitrogen. Just to recap, since our original number of electrons that we drew with single bonds was too many, we tried a double bond, and then we tried a single bond. Start out simple and go from there.